For this video, I'm referencing the class notes. So for the first question, we are simply asked to use all the information we were given to draw the promoter, the start side, the Tata, and the P53 side. So this could be our start side, which would be this direction. And then this whole thing is going to be our promoter. We were told that the Tata goes from -25 to -15. And we are told that the side for P53 is from -100 to -65. So I'm just going to label this P53 side, and I'll write the numbers. And yep, that's all the information for the first question. Then in the second question, we are asked to draw this when the cell is not exposed to UV light. So to redraw everything we already had, the only thing that might change, we might see polymerase attached to the Tata box, but transcription, I would expect that it would not occur, because we were told in the information that we were given that this gene is activated when the cell has experienced DNA damage. Since it wasn't exposed to the ultraviolet light, then we wouldn't expect there to be DNA damage, and we wouldn't see P53 in the P53 site because it only connects or binds to that area when the cell has been damaged. And again, no ultraviolet light, the cell hasn't been damaged, so no transcription occurs here. We are then asked in question number 3 to draw this when the cell is exposed to the ultraviolet light. So if it is exposed, a cell might get damaged, and if the cell is damaged, then we would definitely see P53 binded in the P53 site. We would have, of course, the polymerase and other transcription factors, and I would expect transcription to actually occur in this scenario because, again, we were told that this gene is activated when the cell has experienced DNA damage. Because if it experienced DNA damage, it's definitely going to need to block DNA replication to fix any mutations before they move on, and it will be beneficial that it enhances nucleotide excision repair. So again, transcription does occur in this scenario. Lastly, we are asked to draw this with no P53 on the promoter side. So it would be the same thing, as we've seen, there's no P53 at the end. So to speculate what might happen, we can recall our answer to the first assignment, where P53 was important because it slows down the cell cycle, and then it can do one of two things. It can direct the cell to perform apoptosis, or it can send repair machinery if it deems that the damage can be repaired, so the damage will be fixed. So if there is no P53, neither of those things will occur, and that's going to be a problem because that means that a mutation is likely going to be transcribed.